guys, this is our first CSTR problem. My whole goal here is to be able to do this in 10 minutes. It's not a too hard of a problem, so I take some time here and look at the problem and get to understand what they're asking, and then we can get started, okay? So it's saying that the volume V in the lake is V is equal to 10 to the 7th, right? Meters cubed. Okay, and it's a CSTR with two inlets. So then what we got to do is our general equation, in minus out, plus gen, equals accumulation. Now steady state, that's 0. And our in ones are the two volumetric flow rates, Q1 and Q2. One's from the plant, one's from just the river in stream. Okay? So the first one, they said from just a river coming into the lake, it's 45 meters cubed a second. And you got 5 meters cubed per second coming out of the plant. Okay? So those are our ins. Now we got to have our ins in terms of moles because this is a material balance. So we want to do Q1 times C1 plus Q2 times C2. Concentration coming in from the lake of the pollutant is 0. So C1 is equal to 0, so that goes to 0. Now C2 is 100 milligrams per liter. So what we're going to do is we're going to keep it as Q2, C2 and deal with the units later. Now we got to minus the out, so that's Q out. I'm going to call it Q3 and C3. And we're solving for C3. Now it's a first order reaction. Well, I'll deal with that in a second. Equal to 0. Okay, let's come down here. Now we're solving for C3, so we got to put in a value for RA, and negative RA, really RP, but I'll call it RA, is the pollutant, and it's KCA, like this. Okay, so then you get Q2, C2 minus Q3, C3, minus KCA, which it's not CA, it's C3, because it's a concentration of the lake, because it's a well-mixed lake, like a well-mixed CSTR. So you got to put C3 in for that value. And that will be times V is equal to 0. Now let's solve this thing for C3. So I'll go K2, C2 minus C3 times Q3 plus K, plus KV, sorry, equals 0. Okay, now Q here means volumetric flow rate. Just want to put that in there. I think I skipped on that, but in previous videos that's the value I've used. Okay, so it's added over to the side and isolate C3. So you isolate C3 by moving this to the right-hand side, right, and then dividing this quantity over. So you get Q2 over C2 divided by Q3 plus KV. Now, let's go into what K2 equals. K2 is equal to 45, right? Oh, no, I'm sorry. K2 is equal to 5 meters cubed per second. C2 is equal to 100 milligrams per liter, right? Q3 is going to be the 5 plus the 45 because it's a liquid going in and out, so it's conservation of volume at this point. Meters cubed per second. K is going to be equal to, let's take a look, 0.15 days, inverse. Inverse. And your volume is going to be equal, I think, 10 to the 7th meters cubed, right? Yeah, that's right. Okay, so we got everything we need. But we got to make sure the units agree with each other. And the one unit that doesn't agree with all the other ones is milligrams per liter, and we got meters cubed. So let's turn all those meters cubed for Q2 and Q3 into terms of liters. So Q2 is going to be equal to 5,000 liters per second because there's 1,000 liters in the meters cubed. Now Q3 is going to be equal to 50,000 liters per second. Okay, now we got to turn the volume into liters. So 10 to the 7th, add 3 more to it, is 10 to the 10th liters, right? And then what you've got over here for K is you got to do dimensional analysis to get that in terms of seconds. Day, 1 over day inverse, right? So then you're going to say, okay, 1 day is 24 hours, and then 1 hour is 3,600 seconds, okay? So in MATLAB, you could do this calculation. I believe I already did it ahead of time. 1.7361 times 10 to the negative 6. Right, and a decimal form, 1 is going to be, let's see, 1, 2, 3, 4, 5, 1, 7, 3, 6, 1. Okay, and that's going to be in seconds. So now we got everything we need. Let's put it back in for C3. Q2, which is 5,000. Right? I already know the units agreed because I just took care of that. Now C2 is 100 milligrams per liter. Right? And this is going to be over Q3 plus KV. So that's going to be 50,000 plus K, which is I'm just going to leave as answer. I can do this in MATLAB. times V, 10 to the 10th. Okay, so now let's do this in MATLAB. 5,000 times 100. Now it's going to be don't ask me how I did that. Okay, so 7.422. Yay, that's a good answer. And that's going to be milligrams per liter. And that's your concentration inside the lake. Make sure you have the right amount of decimal units. In this case, I think they went with 1 decimal place. So you're going to be dealing with 7.4. Okay, hope this helped, guys. It was a tricky problem, and it has a lot of unit conversions, so that's always for good practice.